Hello everybody, I will start my today with another coding practice. So in this video, I solved this question. Insert, delete, get random, O of 1, duplicate a route. Okay, so actually in my last video, I talked about the question, insert, delete, get random, O of 1, and not duplicate a route. So it was a medium question, but this is a hard question. So maybe, probably this would be a much harder, maybe. I don't know. Yep. So that being said, I will try to solve this question. So in this question, randomized collection is a data structure that contains a collection of numbers, possibly duplicate, multi-set. It should support inserting, removing, and also reporting a random elements. Okay. So I will implement the data structure class randomized collection, which should have insert method, which I insert item var to the multi-set. Yep. Even if the item is already present. Return true if the item is not present and false otherwise. Yeah. Okay. I return true if the item is not present. Yeah. So if the item exists, I should return false, but still I insert an item into this collection. Yeah. For remove method, I remove an item. Yeah. And return true if the item present, false otherwise. Note that var has a multiple occurrences in the multi-set. We only remove one of them. I see. So even if I remove true, it is possible that the element var still remains in the multi-set. Okay. And I will implement GetRandom method, which returns a random element from the current multi-set of elements. Okay. Yeah. And yeah, probability that some number should be returned should be proportional to the number of elements in the multi-set. Okay, so that being said, I must implement the functions of the class such that each function works on average of one time complexity. Note that test case is generated such that it gets random variable only code if there is at least one item in the randomized collection. Okay, so get random. When get random is called, it is guaranteed that there is at least one element in the randomized collection. So I just don't have to take care of the case when there's no element, but I have to return the random value. Okay, so I think the question is quite clear to me, and thankfully there is a example here. So your randomized collection object will be instantiated and corrected as such. Yeah. So let me quickly, confirm my understanding with some examples. So I initiate the randomized collection, then I can insert some number. Then if I insert two numbers, actually this should be 11, 11, 11, two 11s now. Yeah. And for insert method, I should return true if the item is not present. I should return true here. And here, I should return false because 11 is already exists internally. Okay. Then I can call remove method. So when I call the remove method, true if item present, false otherwise. So this exists, so this is return true. And now internally, only 11 exists. And if I remove 11 again, it still exists, so it returns true. And now the internal there isn't any element. But if I call the remove 11 again, this returns false because 11 doesn't exist anymore. Yeah, and that's it. And for random method, say here, if I insert like 22, then it should be like this. And if I call the GetRandom method here, it should be 11 for 66% and 23 for 33%. Okay. Yep, I think now I've clearly understood what I should do in this question. So let me think of the algorithm. So I actually solved the insert delete get random of one duplicate not allowed question, which was medium before. So I basically have the core idea of this question, I think. So I think I will try to apply that approach into this question. So, okay, so basically what I used for this, okay, the challenge of this question is, okay, so wait a minute. So if I have to implement only insert method and remove method, I can use a hash set internally. Oh, actually in this case, hash map of the counter, number to count, hash map. That's enough. And with that, insert and remove should be constant time complexity. However, I have to implement GetRandom method. And unfortunately, I cannot use hash map, GetRandom method with the counter hash map. So, one of the possible approach is that I initiate the list like 11, 11, 20, 20, 20, allowing duplicates. And I use the Python random.choice method with this. In this way, I can choose the element randomly proportional to the number of counts. Yeah, so that works. However, um, converting the counter hash map into the list takes linear time proportional to the number of elements, total number of elements. So it doesn't work. So the approach I used to work around this is I basically keep track of the element in array like this. Yeah. And for, also, obviously, I have to keep track if the number exists or not. I have to find it immediately. So, yeah. Yeah. So in the case, say, if I'd like to append 11 to this, data structure, I just can append it to the tail of the list in the constant time. However, remove is a problem. So say if I'd like to remove, say, 22, I have to find it and then I have to remove it. And in this case, the order of the element in num's array doesn't matter. I don't use that information anywhere in the operations. So yeah, and that being said, firstly I have to find 22. Then I swap 22 with the last element. So now it becomes like this. Then I can delete the last element, which is now 22. Yeah. Yeah. So in this way, I can remove this element from the nums array. However, the problem is that it takes linear time to find number 22. So what I can do for this approach is I keep track of the index of 22 or any other number with hash map like this. And obviously, number 22, I mean, there may be multiple number 22, maybe 2 or 3 or 4, but I have to keep the indexes as the list in this way. Yeah. So if I do this, say I'd like to remove 22, I can look at the num2 indexes in the hash map, and I find the index of the 22. Then my task is to swap 22 with the last element, which is 11. So I do it. Yeah. And then I remove 22. Let me write it down. So I swap it with last index. And also I have to update the hash map too. Let me call the nums as array list, and let me call num2 indexes as a hash map. And then I will remove and also I have to update hash map 2. Yep, so this is how it works. However, the only problem is that yeah, I think this works. Oh, so let me change the data structure a little bit. For num2 indexes, this should be num2 set of indexes. Yeah. This is because in line 32, when I remove the last one from the array list, so what happens is that, say in this case, like 11 has like this. Yeah, this is just an assumption. So let me show you what's my concern. So for example, in this case, firstly, I will take a look at number 22 and I find the index 2. And also I find that I should swap with number 11. So I take a look at the key number 11 and find these elements. Oh, and the problem is I have to find the largest index in this. But in this case, I can just take a look at the last index, last one, which is index 7. But I'm not pretty sure if this is always sorted. Yeah. And probably not, because, for example, if I swap 22 with 11, now 22 is updated with, wait, oh, sorry, no. I take a look from the last index. Sorry, so I swap with the last index in the array list because, I mean, popping an element from array I mean, the last index removal takes only the constant time, but obviously the head element removal takes linear time. I remove the last element. So when I remove this element, this one is still the largest index, so it's okay. But for 11, what happens is that now 11 is updated with index 2. So I choose 11, swapping target 11 from the last element. But when I swap this with index 2, this becomes index 2. And the consequence is that this index array is not sorted. So next time when I try to swap, so when I try to swap with last element 11, I will take a look at this key 11 and find this hash map, no, this list, index list, and I take a look at the last element, but it's not the last index. That's a problem. So I think the workaround here is that, number one, do the linear scan every time, but it takes linear time. So I think I can use the heap, probably, max heap. So in that way, I can pop out the largest element in the log time. Yep. And for, the line 36, finds index of removed num in hash map. Yeah. For this also works with log time, because popping out element from the heap takes log time. Yeah. Yeah. But still at log time, I have to make it constant time. I see. Mm. Okay. So what should I do? If I remove 22, I see. I think this is the biggest challenge in this question. Mm, mm, mm. So again, my task is to remove 22 from this array list. Yeah. So What it means? So 22. If I swap is 11, now 11 comes here as index 2, so that's a problem. I think I can use maybe double linked list for this insertion too. No, I can't. No, I can't. Okay. So let me think the way. Okay. Yeah, I think I should use some examples. Okay, so for example, if I try to remove 22 from this array list, I'd like to say remove this one. Then how I can remove this? So I thought of swapping it with 11 and popping a 22, but now 11 indexes is messed up in that way. Yeah. Wait, do oh, I think okay. Initially, I said I'd like to use the list, and it doesn't work as I said because with the list, the order is messed up. Okay, so I think maybe I don't have to use heap. Maybe just set is enough. So let me, review my idea again. So what I wanted to do is, firstly, I will take a look at number 22, and this can be any index of 22. I can choose this or this, anyone is fine. So, but in the case of using the list, okay, so I was kind of messing up my ideas. So now I found this. So when I try to use the list of indexes, I had to put the biggest number, biggest index in the end because that, yeah, otherwise I cannot remove that index, biggest index from the list. However, if I use the set, it wouldn't be a problem because when I choose a 22 to be removed, I can choose any index from this set. I just have to pop out one element from set. Then I will try to swap it with the last index. So from this, I can find number 11 and I get index, say, 7 here. And as long as this is the set of indexes in line 33, I can just remove the index numbers 7, index 7, sorry, from the set in the constant time. So it works. Yeah. So I can say I just have to use the set and everything works. Okay. So in line 37, find the index of removed num in hash map. This is okay. This can be random index. And then in line 38, swap it with last index in array list and update hash map 2. Okay, this is possible in the constant time. Then in line 39, remove last one in array list and update hash map 2. Yep, this can be done in the constant time. Good. Okay. So I think I can make all of them in the constant time. So yep, let me work on the implementation. Oh, by the way, the space complexity should be O of n because I use firstly nums array. Okay, array assumes that the number of elements which has been inserted so far without is n, and there's no removal yet. In that case, number of element is n, so nums array should be n elements. It's O of n. And for nums indexes hash map, the number of total element in the values should be O of n. And for keys, at least I can say, even if all the numbers are unique, I mean, if number of keys should be up to n, which is in the worst case when all the numbers inserted so far are unique. Yeah, so key and value should be O of n for each. So in total, it should be O of n. So O of n plus O of n is O of n. So that's the space complexity. Okay, so now I start the implementation. So as I said, I will have the nums array. Then I will have the num2 indexes, which should be num2 set of indexes. Good. And in line 56, I implement the insert method. So for insertion, I will check if already present or not. If, yep, I can find any index of this value. Sorry. If it's not found, it is completely new. Otherwise, it's not new. And I will return this flag in the end. And in either way, I have to insert this element. So after appending it, I can find the index of this should be this. Yeah, so, okay. So basically, firstly, I append the value to the nums array list. Then I can find the index where the element was appended. It should be ranks of nums minus 1. So I register it to the num2 indexes. Okay, good. Next, I will implement the remove method. But let me quickly implement GetRandom method because it's much easier. Yep, I can just have to do it. The random.choice method picks up one element from array list. So this is good. Okay, so now I will implement remove method. So here in line 37, okay. I will check if num already exists or not. So I can find it in this way. Wait. Okay, good. So if no, is found should be larger than 1. Yep. If there is any index with that value, it exists, bar is found. So if bar is found, yep. Firstly, in line 37, find index of remove num in hashmap. So this is a random index of any bar. I mean, index of any bar. So I can get it in this way. And now it is popped out. And also, I will take a look at the last index. Wait, so last index should be, this. So now I've got value index and last index. So I swap them in the array list. Okay, so now swapping is done in the array list. So what I will do next is update the hash map accordingly. So first three, I'm talking about the first thing is to do is I pop out the, no. Okay, so here in line 68, 70, I clarified, value index and last bar last index. So in line 37, what I should do is I delete the last index. So from this. In this way. So now from num2 indexes, bar index and last index is deleted. So now I will, append the new result. In this way. Okay. Then in the end, I will remove the last element from the list. Which should be bar. Then also, I unregister it from the num2 indexes array. But obviously, I just don't have to skip line 70. Wait, 5. Okay. So that's it. Good. Then I return is found. Okay. So that being said, let me work through my code. Let me sync with this example. Okay. So firstly, when I try to insert 11, in line 63, length of num2 indexes bar, which is, I mean, this is now empty set. So this is new. So if new is true, so this returns true. Okay. And in line 65, I append so 11 to the nums array, and also bar index. Yeah, bar index is 1 minus 1 is 0. So for num2 indexes, I have 11 to set 0. Good. Then I try to insert 11 again, and now is new is false, because in num2 indexes, the value of key 11 is set of 0, so it ranks is not 0. Okay, so in line 69, I append this bar, which is 11 again. Yep. Then in line 70, I guess the index 1. So now num2 index is like this. Good. And I return false. Okay. Then I try to insert 22. I skip the detail because I'm pretty sure this is it. And this returns true. Then now we get random mess. No, remove 11. Okay. So firstly, I will check is found, and this should be true because in num2 indexes hash map with key 11, it is a set of 0 and 1, which is ranks 2. So this is found. Okay, and in line 78, I get bar index from num2 index bar. So I'm removing 11, so I will take a look at this set and pop out one element. Let's say I remove 1. So now bar index is 1. Then last bar should be now 22. And last index should be 3 minus 1 is 2. So far it's okay. So in line 82, I swap bar index and last index elements. So now this becomes like this. Yep. Then in line 83, the last bar was originally 22. So I removed 22 to index 2. Oh, sorry. In line 56, this was 2 actually. And this is removed now. Okay. Then in line 86, num2 index is last bar, append bar index. Last bar was 22, and bar index was, 1. So 1 is appended here. Okay. Then in line 88, nums pop bar, nums pop. So now 11 is out, which is exactly the number I'd like to remove. Okay. And I return is found, which is not true. Okay. Let me take a look at these two data structures again. Nums is now 11 and 22, and num to indexes is 11 to 0 and 20 to 1. Yeah, exactly as I expected, so it's okay. Yep, and then finally, if I try to get random, yep, now it has 11 and 22, so it should be randomly chosen from these two elements. Okay, now I'm pretty confident on my code, so let me execute. So this should be odd because this is set. Good, I submit my code. Oh, so this is a case insert 1, remove 1, insert 1. In this case, key error 0. Remove is failing. Yes, remove is failing, obviously. I see. So probably this is a case when there's only one element. So yeah. Var index is equal to last var. Sorry, var to be removed is equal to the last var. So that's the edge case I forgot to cover. So in this case, what should I do? So probably the problem is that the num to index this var is popped out like already. Yeah. Okay. So let me write it down. So nums has only one element, which is 1. Num to index should be 1 to index 0 only. So it now looks like this. And the problem is that firstly, I pop out index 1, number 1 here. And I decide that 0 should be removed. Then I will take a look at last bar, which should be 1. And last index should be 0. And in line 87, I swapped the elements. The internal nothing happens. Then here in line 88, I try to remove 1 from last index. No, last index 0 from this set again. So that's a problem. Okay. And also I think this can happen when the nums is like this, and I will try to remove 3. In this case, what I'd like to remove is this 3, and actually, so I swap this with the last element 3, but it's also the case. Let's see. So I think the most, easiest way to avoid this is I get index 0. So this should be any of them. Then, so here I didn't remove this var index yet. Then in line 91, I remove this. Yep. So I think this is the most, you know, um, yeah, safe way, because now this is not, wait, even that being said, still, yeah, when I try to swap 0 and 0, I'm removing it twice. Okay, so let me quickly reverse my changes. And let me say here, if no, they're not the same, I remove it. Okay. Yep. I think this is a workaround I can make. And I actually do it also here. Either is fine, but for the clarity, I do it in this way. Okay, yeah, I think this is not quite clear. Okay, so now I'll submit my code again. No, it now fails. So let me think a bit more carefully. Okay. So originally I was this. And the thing I wanted to do is I have to think of the edge case when bar index is equal to last index. Yes. So I did it in this way. If they're not the same, wait, so if they are the same, okay, so I see. So I'm thinking this is power index, last index. Okay, so if I try to, let me change it to rebel. Yeah, so in this case, I try to remove, say, 22 in this case. No, if I'm trying to remove 33, the problem is that bar index is 2 and rust index is also true. So I actually don't have to, swap it. Yeah. So what I can do is, if there's this, okay, so let me do it. Clarity. Firstly, I will do this if statement. Yeah. Then I also include this operation into this if statement for clarity. So let me check. So if they're the same, what I should do is just drop it out. Yeah, so this is it. Okay, so this is what I should do. And if they're not the same, oh, and actually in here in line 87, I'm popping out, but I don't pop it out here. I just take a find one var index here, this way. And in line 95, I will think of the case when they're not the same. I mean, last element and the element to be removed are not the same. So in that case, I swap them. Then I update the hash map. So now I remove this and this. So now I've removed it, and also I have to append it. I mean, yeah. So now it completely, swapped. Then I have to drop the last element. Yeah. And if when I do this, this is exactly the bar to be removed. I actually don't have to do 98. Yeah, because this is something to be dropped, right? Okay. So now I'm pretty sure on this. So let me execute my code. Okay. Ah, not subscriptable. How can I get some element here? Is there peep message or something? No. Yeah, I think the workaround is this: seeing it and then move it back. Okay, accept it. So I submit my code. Good, now it's accepted. Okay, so let me quickly wrap up my today's coding practice. So today in this video, I solved the question, insert, delete, get random of one, duplicate a route question. And in this question, I'm expected to implement the data structure named randomized correction, which has three methods. Number one, insert method. Number two, remove method. Number three, get random method. And all of them has to be work in the constant time. Yep. And if this has only insert and remove method, it works just with the internal hash map of the num2 count counter hidden out. But in this question, I have to implement GetRandom method. It makes this question challenging because I cannot use the random dot choice method on the hash map values. I have to construct the list from the counter and use random dot choice on that list. In that case, GetRandom method takes linear time. So that I wanted to avoid. Yep. So as the workaround, I use two data structures. Number one is, where is it? So number one is array list. Number two, hash map. So array list has all the nums which is stored in this data collection. And hash map has the indexes, number to indexes mapping. So in this way, when I'm told that I'd like to remove number 22, then I can find the index from this hash map. Then this is a little bit of technique, but I swap that 22 with the last element in the array list. Then I pop out the 22 from the nums array and also update the hash map accordingly. To realize this, the num to index should be num to the set of indexes, not the num to the list of indexes. Yep. Okay. And one thing I had to really take care is that in the case when last index and value index, the number to be removed, the nums and the last element is the num are the same. Yeah. If they're pointing to the same element, I have to think of this as the edge case. So that's what I overlooked. Okay, so this is it. Yeah, thank you so much. Bye.